Hi, and welcome to this third part of tutorial, Structure of a C program. In the first part, we have studied history, a bit of history of C programming language, and what advantages does it offer. In the second part, we learned how to set up a work environment, Eclipse as our IDE, GCC as our compiler. Java was needed for installing Eclipse, and Cvideo was needed for GCC. GDB is our debugger. So we move forward and we proceed by trying to learn about structure of a C program. The first line states that a C program is composed of functions. So first we should know a bit about C, that how it is composed of functions. C programming is about structured programming. In structured programming paradigm, you split a problem or task into small subtasks, and then for each small subtask you write a function. So essentially we will have a task, we will have subtasks, and then for each subtask we will have a function, and combination of all the functions will solve our bigger problem. So we can say a C program is made up of functions. There are other elements also, like macros and comments and headers, etc., variables, but more or less it is composed of functions. You may also ask that what is the advantage of splitting the C program into functions? Well, the advantage is like this. Consider you have to write a program which has, say, 20 tasks or functions. Now suppose you have to write another program in which you have, say, 50 functions, but you find that 5 functions are common. So by writing these functions you can reuse them, but if you write all the functions and combine them together and write a big one, then you cannot use. It's like this. Consider you have to build a house, and you can add brick by brick to make a 10 by 10 home, or maybe 20 by 20 home. But suppose this, if you get a wall of 20 by 20, then can you build a 10 by 10 house using a 20 by 20 wall? No, you cannot. So this is a very useful feature of C programming, and it is one of the reasons behind its success and the timing on which it came. Second line emphasizes the fact that main function is a special function. Now this main function is a special function. Why? Because it is the entry point of operating system for execution of program. When Mr. Ritchie invented the C programming, he had to choose an entry point, and he chose the name main for that function. Otherwise, operating system will have no information that in a binary where to start execution. So main is that entry point. Now, C99 and NC standards specify 2 types of signature for main function, and they say that every C program must have main function in a hosted environment, not in a freestanding environment. We will see about hosted and freestanding environment. So main is a must in a hosted environment. Normal environments in which we use Windows or Linux or Mac OS are hosted environments. So main is a must. Any standard specification conformant program will have a main function. The third line says it contains local and global variables. What are local and global variables? A local variable is one which is declared inside a function. For example, int I. When we say int I for the first time inside a function, that is marked as as a declaration. So you say I am declaring this variable int I inside a function. So when you say inside a function, it becomes a local variable. And when you declare a variable outside all the functions, then it becomes a global variable. A local variable is accessible to that function only, and it can be accessed in other functions only if it is passed to that function. There are two ways to pass, by value and by reference. We will see that when we will learn about functions. A global variable, on the other hand, can be used throughout the scope of global variable. That is, you can have a global scope and the variable can be used almost anywhere. If you want to use in another file, you have to get its name through external storage specifier. There are two more types of variables, file scope variable and block scope variable, but in general, a file scope variable is a global variable and a block scope variable is a local variable. There are specific types of these two types. Next is headers and comments. What are headers? Headers are files which contain prototype declarations of functions and macros and structure declarations, and they include other headers also as a dependency. The standard library has around 24-25 headers, and they allow a wide variety of functions and facility of having variables for representing various data types, which help us in common day-to-day programming tasks. Similarly, we have comments. By commenting your code properly, you can make it readable, maintainable, and fun to read, enjoyable to read. Suppose you write a big program but you do not put any comment anywhere, and you have chosen bad variable names, bad function names, and your indentation is not proper, then it becomes difficult to read and understand that program. So that's why you put comments. Next is macros. There are several types of macros. The most common are hash defined, which are for text replacement and also for simulating function like behavior. Then we have hash include macros, which we see for header inclusion and other file inclusion. You can include a C file also, but mostly they are used for header file inclusion. We have conditional compilation and conditional code inclusion macros like ifdef and endef and elsif. We also have special purpose macros like underscore underscore line underscore 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 file underscore underscore, and we also have pragmas. So there are various macros. They are very powerful and quite easily you can misuse them. Next is we have comments. I cannot emphasize the value of commenting because it is so much essential for a programmer to put proper comments. In the beginning, C had only one type of comment, that is a multi-line comment. A multi-line comment starts with /* and ends with */. Anything between these two will be ignored. However, there is a minor gotcha which we'll see where it can cause trouble. One-line comments were taken from C++ during C99 standard release, and it's pretty easy to use. You put two // close together without space, and the entire single line will become a comment. It does not matter what comes after them. The C program can be organized into multiple files for the sake of reuse, or for the sake of simplicity, for the sake of organization. And it can also be written in one file if it is a small one, but any real world program consists of multiple files. As I said, there are local variables and global variables. These variables can be simple in the sense primitive, single character or integer, real numbers like float or double, or booleans, or even complex numbers. Then we have derived types, arrays and pointers. Both can be point to or composed of char. You can have array of char, pointer to char rather. You can have array of integers, pointer to integers. There is one small difference between them, that arrays are located on stack and pointer is located on heap most of the time. Pointers can also be on stack though, under certain cases. Also, there is one more difference, that you cannot declare a you cannot declare array to void, but you can declare pointer to void, which is a generic pointer and can point to anything. You can have a multi-dimensional array and pointer to pointer. You can have, say, n-dimensional array, and you can have n level of pointers also. We have also got compound types like structures or unions, which are useful to represent real world objects, and later we will see the advanced uses of structures and unions. We have two types of constants. One are real constants, which you can have by using the keyword const, and the second is symbolic constant, which is called enum. To control the behavior of the program, we have control flow statements in the form of if, else if, and else. They can be used together or can be used separately. Else if and else are always used with one if, but if can be used alone. Else if and else cannot be used alone. We also have switch, case, go to, return to control the flow. And for iterating over a sequence, we have got three types of loops. One is for loop, another is while, and one more is do while loop. Typically, we iterate over a sequence of arrays, or we loop over string, and sometimes we also loop over a pointer if we know how many elements it is pointing to. Then we have simple expressions and compound expressions. There are primary expressions. Various types of expressions are there. For example, a is equal to a plus b, c is equal to a plus b whole divided by 2, and so on. The compilation process is divided into several tasks or several stages. GCC is a multi-pass compiler. The first pass is pre-processing pass, which you can examine by typing the command gcc space -E space filename.c, and you will see your output on your screen. In the pre-processing stage, first line continuation character / is removed. Then macros are replaced, all the macros, and after that, then trigraph sequences are removed, and then macros are removed. In the second stage of compilation, the pre-processed output is fed to GCC, and it produces an object file, which is the instruction to the CPU. In the third stage, the object file is linked with the library files to get the definitions of functions which we call from other programs. For example, if you call a function printf, then the sequence of instructions of printf is looked up into the libc shared object or libc.so, and those instructions are then put in the binary if you are using static linking, or their address is recorded and put into the final binary. Linking is done by the linker LD, but typically we do not invoke LD manually. We allow GCC to do these stages automatically. So that completes this part of tutorial, which is structure of a C program, and see you in the next part of the tutorial. Till then, happy coding, enjoy.